Welcome friends, this is my new YouTube channel and I'm going to discuss about biochemistry. So I'm starting my biochemistry with first very simple molecule, that is carbohydrates. Carbohydrates. In this short lecture, I'm going to discuss about definition and classification of carbohydrate. Classification of carbohydrate. So let us first consider about definition. Definition definition of carbohydrate. So before we discuss about definition of carbohydrate, let us just look at the structure of glucose so that the understanding of definition becomes very much clear. So glucose structure, it is 6 carbon in the straight chain. So I am just drawing the 6 carbon in one single chain. Okay, on the first carbon there is aldehyde group, and on the last carbon there is CH2OH group. So there is one trend, there is one like rule that on the first is aldehyde group, second, third, fourth, fifth, and sixth. So always the numbering pattern always start opposite to the CH2OH group. So CH2OH, that carbon will always be a last, and its opposite terminal will always be a first carbon. So this is the rule, and uh, like whenever you find yourself in difficulty while giving this numbering, always try to look at the CH2OH group. The opposite end is the first carbon. Okay, now as far as this glucose structure is concerned, now rest in the middle, 2, 3, 4, and 5, fifth carbon, there is one OH group and one H group. So all have similar except for the third carbon. In the third carbon, particularly in the glucose, this OH group is on the left side and H group is on the right side. Rest everywhere, OH group is on the right and H is on the left. Okay, OH on right and H group is on the left. OH group is on the right and H group is on the left. Now this particular glucose structure is D glucose. See, this D is capital. Okay, you need to remember it that this is for the capital D. Now what decides that it is capital D? So for that you look at the terminal carbon and put up a -1. So 6 minus 1 is fifth. So around this fifth carbon, look at the OH group configuration. If this OH is on the right side, that means it is D sugar. If this OH was here, if this somehow OH is here, then it is L glucose. Okay, in the human we find D glucose. Okay, so now by looking at the structure, we can identify two characteristics. One is CHO, that is aldehyde group. Okay, and second one is it is a alcohol. Now you can see this alcohol group is not single. There are many alcohol groups. Okay, many alcohol groups. So that is polyhydroxyl alcohol, or instead of polyhydroxyl you can use word polyhydric. Okay, now one more thing about this, our first point, that aldehyde group, sometime instead of aldehyde group they contain CO group, that is keto group. So this keto group containing sugar is fructose. We are not going to draw its structure, we'll see in the future videos. So now if I want to define the carbohydrate based on this structure and based on some derived observation, that one is the carbohydrate contains aldehyde or keto group and polyhydric alcohol group. Okay, and second is if certain like polymeric substance, if you do hydrolysis and find such substances as a hydrolyzed product, then at that time you will consider polymeric such polymeric substance as a carbohydrate also. So the consensus definition for the carbohydrate is carbohydrates are defined chemically as aldehyde or ketone group containing polyhydric alcohols, or some polymeric substance which on hydrolysis give such a substance. These are known as carbohydrates. These are known as carbohydrates. This is the definition of the carbohydrate. Now let us move on to the classification. Classification. Okay. Classification. So there are so many schemes of classification, but one simplest scheme I found is first divide all the carbohydrates into four groups based on number of its monosaccharide unit, number of its monomer unit. So first one is all obviously a monosaccharides. Second one is disaccharides. Third one is oligosaccharides, and third one is polysaccharides. Polysaccharides. Let us first consider about monosaccharides. What are the monosaccharides? Okay, monosaccharides, as its name suggests, mono means single. Now if there is single unit and if you hydrolyze it, you will not get anything. Okay, so this is simply a non-hydrolyzable. You cannot hydrolyze these monosaccharide units into further smaller unit. Okay, that's why it is monosaccharide. There is no hydrolysis possible. Okay, so because of these, it is also known as simple sugars. Simple sugars, because they cannot be broken down further. Now again there are two groups. Okay, like based on the number of carbon, like someone has 3 carbon, some monosaccharide has 4 carbon, some monosaccharide has 5 carbon, some monosaccharide has 6 carbon. Also okay, also it might have aldehyde group, or it might have keto group. Okay, so if some monosaccharide is 3 carbon, we can collectively call it as a trioses. If 4 carbon, we can call it as a tetroses. If 5 carbon, we can call it as a pentoses. This is collective name. It is this pentoses, tetroses, trioses doesn't indicate a single compound. It is a group of compound. Any monosaccharide you come across and you can see that it is 3 carbon, you can call it as a trioses. Similarly, 4 carbon tetroses, 5 carbon pentoses, 6 carbon as a hexoses. And we seen earlier in the glucose that it is 6 carbons. Okay, 6 carbon. So we can simply understand that glucose is one of the group member of this hexoses, right? Okay, now let us take again, this can be further subdivided into two, that some trioses might containing aldehyde group or some trioses might contain keto group. So let us take one example. If you look at one sugar and you find that okay, this is 3 carbon and aldehyde group. So one example is glycerose. Okay, so this glycerose it is 3 carbon and aldehyde group. Okay, there can be many more monosaccharides over here, but this is one prominent example. So we are right now we will consider only single compounds. The ketoses is dihydroxyacetone. For the tetroses, there is one erythrose in the aldose group, and for the ketose group, which is 4 carbon, and one example is erythrulose. You can see extra U and L are added into the erythrose. For the pentoses, which is aldehyde group, it is one of the example is ribose, and for the keto group there is ribulose. For the aldehyde group we just discussed, it is glucose, and for the keto, which is 6 sugar, there is fructose. Okay, so this was the classification of monosaccharides. Now let us look at the disaccharides. Okay, our second is disaccharides. Disaccharides. Okay, as in the name di, that means two. So when you hydrolyze it, on hydrolysis, the disaccharides give two monomer units. Two monomer units. Okay, so its examples. Let us look at the examples. There is a maltose. There is a sucrose. There is a lactose. Maltose, sucrose, and lactose. Okay, if you hydrolyze it, this maltose gives two molecules of glucose. Two molecules of glucose. If you hydrolyze sucrose, it gives one glucose and one fructose. One glucose and one fructose. If you hydrolyze lactose, it will give one molecule of glucose and one molecule of galactose. Okay, see, glucose is common in all three: maltose, sucrose, and lactose. In the maltose, second molecule is also glucose, but in case of sucrose, second molecule is fructose, both containing R. So you can easily remember. In the lactose, one is glucose and other is galactose. Okay, one is galactose. So by this manner, you can easily remember it. Okay, now now our third group is oligosaccharide. Third is oligosaccharides. Oligosaccharide. Here, this oligosaccharide, this oligosaccharide, if you hydrolyze it, it gives you 3 to 10 monosaccharide units. 3 to 10 monosaccharides on hydrolysis. Now there is one example, that is maltotriose. Maltotriose. If you hydrolyze maltotriose, you will get 3 molecules of glucose. 3 molecule of glucose. Don't get confused by this triose word. Okay, in the triose, we seen in the monosaccharide, that it is 3 carbon containing monosugar. But here, maltotriose, it doesn't mean that it has 3 carbon containing. See, glucose, glucose. These all have 6 carbon. Okay. Here the triose is indicating something else. I will call it as a misnomer. Okay, it is breaking the rule. Okay, and the last and most important carbohydrate group is polysaccharide. Polysaccharides. Okay, its other name is glycans. Glycans. Now these polysaccharides are defined like when you hydrolyze it, and if you get more than 10 monosaccharide units, you consider that parent compound as polysaccharide. Now there are two groups. One is homopolysaccharides, and other group is heteropolysaccharide. Heteropolysaccharides. Okay, homopolysaccharide and heteropolysaccharide. Now you can see homo means the same. Okay, so simply if you hydrolyze these and you get all the monomer unit being only one single type, you will consider it as a homopolysaccharide. In case of hetero, that means different. Hetero means different. So when you hydrolyze these and you get two or more different types of sugar, you consider it as a particular substance as a heteropolysaccharide. Okay, so here homo, it is a polymer of same monosaccharide units, and in case of heteropolysaccharide, it is polymer of different monosaccharide units, right? Examples of homopolysaccharides are starch, glycogen. Okay, starch and glycogen both are polymers of glucose. Like it may have branching also. So when you hydrolyze it, you will get only single type of a single type of monosaccharide unit. Here on the heteropolysaccharide, it is its name is mucopolysaccharides. Mucopolysaccharides. This is not example. This is simply other name for the heteropolysaccharide, and it's also known as glycosaminoglycans. Glycosaminoglycans. We are going to discuss about mucopolysaccharide and like glycosaminoglycans in a very great length. These are very important. It is difficult to understand, but believe me, just stay with me. I'll make this as a very easier for you. Okay, so that completes our today's goal, that is definition and classification of carbohydrates. Thank you.